In this video I'll be discussing what the Fundamental Theorem of Calculus Part 2 states and how we can use it to evaluate definite integrals by hand. The conditions of the Fundamental Theorem of Calculus Part 2 are as follows. F needs to be continuous at every point on some closed interval AB, and capital F is any antiderivative of f on that same interval AB. If both of these things are happening at the same time, then the integral from a to b of f of x dx is equal to capital F evaluated at b minus capital F evaluated at a. So in English what this means is you're going to find the antiderivative of lowercase f, and you're going to evaluate it at the upper limit, evaluate it at the lower limit, and then subtract the results. I think it's important to note as well that in this video it's assumed that the viewer has a command of some simple antiderivatives, so I will not be discussing that in detail here. Okay, so suppose we want to evaluate a simple integral like this, the integral from 2 to 5 of x squared dx, and we want to do this completely by hand. So a common notation here is to put the antiderivative of x squared in a set of squared brackets, and then put the limits that we intend to evaluate the antiderivative at on the right side as shown here. Substituting in the limits, we get 5 cubed over 3 plus c minus the quantity of 2 cubed over 3 plus c. And note that when you distribute the negative sign here, you'll note that the constants of integration just simply cancel out. So for the next example, I'm not even going to bother writing down the constant of integration, since this is always going to happen every time you evaluate a definite integral. The constant of integration is just going to subtract itself out. Alright, so simplifying all of the arithmetic here, we end up with a result of 117 thirds. Alright, so here's just one more example involving trig. So the integral from 0 to pi over 2 of 1 minus the sine of theta d theta. Again, I think it's easiest to think of the integral like this, as two separate integrals. And if you recall from property of integrals, if you integrate a constant, it's just the constant times the difference in the limits. So this first one's going to simply evaluate to pi over 2. And the other one, recall that the antiderivative of negative sine theta is cosine theta. So now we have pi over 2 plus the cosine of theta evaluated from 0 to pi over 2. Subbing in each limit and simplifying the results, we have that this integral will be equal to pi over 2 minus 1.